Aliceball arrives at the College of Hawaiʻi in 1915, a young chemist with a sharp mind and quiet determination. She has just completed her master's thesis on kava root chemistry, becoming the first woman and first Black American to earn the degree. Her work catches the attention of Dr. Harry T. Holman, a physician at College of Hawaiʻi Hospital who is searching for a better treatment for leprosy. Holman approaches her with a challenge. Chaulmoogra oil, the only known treatment for leprosy, is nearly useless in practice. It is too thick to absorb when injected, and when swallowed, it causes violent vomiting. Patients suffer in isolation, many exile to Molokai. He asks if she can find a way to make it work. Alice begins studying the chemical structure of chaulmoogra oil, isolating its fatty acids, hydrocarpic, chaulmoogric, and gorlic acid. These compounds are highly lipophilic, resisting water and making absorption impossible. She reads through existing research, including work by Frederick Power, but finds no solution that allows safe injection. She hypothesizes that modifying the fatty acids into ethyl esters could increase solubility. The process requires saponification followed by esterification. If successful, the oil would dissolve in water and enter the bloodstream without clumping under the skin. In the lab, she tests small batches, adjusting temperature and reagents. Each failure narrows the path. After months of trial, she produces a clear, water-soluble solution. It remains stable and retains the oil's therapeutic properties. She administers the compound to animal models. The results show consistent absorption and no adverse reactions. The modified oil enters the circulation efficiently. For the first time, a viable injectable form of chaulmoogra exists. Holman reviews her findings and agrees the method is effective. He plans to begin human trials at College of Hawaiʻi Hospital. Alice prepares to publish her results, writing drafts of a paper that will detail her chemical process. But Alice becomes ill in late 1916. She returns to Seattle for medical care. The cause is unclear. Some suggest chlorine poisoning from a lab demonstration, though her death certificate lists it as speculative. She dies on December 31, 1916 at age 24. Her research remains unpublished. Her notebooks are left behind at the College of Hawaiʻi, accessible to faculty. Her work is incomplete in the scientific record, but her method is documented in her notes. Arthur L. Dean, her graduate advisor and the dean of the college, gains access to her notebooks. He begins replicating her experiments. By 1919, the chemistry department produces large batches of the injectable oil for clinical use. Dean publishes the method in 1919 without mentioning Alice. He describes the ethyl ester modification as his own development. The treatment becomes known as the Dean method, taught to medical students and adopted across Hawaii. At College of Hawaiʻi Hospital, physicians begin injecting patients with the new formulation. Many show improvement, lesions heal, strength returns. In 1920, 78 patients are discharged, able to leave isolation for the first time in years. Holman writes a paper in 1922, giving full credit to Alice. He names the treatment the ball method and states there is no improvement in Dean's version over her original technique. He emphasizes that any physician can replicate her process with basic equipment. His article is published, but it does not shift the scientific consensus. Dean continues to be credited. The Dean method appears in textbooks, medical reports, and pharmaceutical records. Alice's name fades from view. Decades pass. The treatment remains the standard until sulfonamide drugs emerge in the 1940s. By then, aliceball is forgotten in official histories. Her contribution is absent from university records and scientific literature. In the 1970s, Kathryn Takara and Stanley, faculty at the University of Hawaii, uncover Ball's research. They locate her thesis, lab notes, and Holman's 1922 paper. They begin advocating for her recognition. They publish articles restoring her role. They contact historians, medical journals, and university leaders. Their work gains attention, but institutional change is slow. In 1990, Ali discovers a 1932 book, The Samaritans of Molokai, which mentions a young Black chemist who developed the injectable oil. The description matches Alice. The citation provides independent confirmation of her impact. The University of Hawaii honors her in 2000 with a plaque placed beneath a chaulmoogra tree behind Bachman Hall. The tree was planted decades earlier, a quiet witness to her forgotten work. In 2007, the Board of Regents awards her the Medal of Distinction, the university's highest honor. It is given posthumously, decades after her death. Students begin calling for Dean Hall to be renamed in her honor. The Earth Sciences Building still bears the name of the man who took credit for her work. In 2016, a short film, The Ball Method, premieres at the Pan-African Film Festival. It brings her story to a wider audience, highlighting the injustice of her erased legacy. The London School of Hygiene and Tropical Medicine adds her name to its frieze in 2019, alongside Florence Nightingale and Marie Curie. It is a rare honor for a scientist whose work was once ignored. In 2020, a satellite named USAT-9, or ALICE, is launched into orbit. Its COSPAR designation is 2020-79A. It circles the Earth, a quiet tribute to her forgotten brilliance. Governor David Ige declares February 28 Alice Augusta Ball Day in Hawaii. The proclamation is signed at a ceremony near Bachman Hall under the chaulmoogra tree planted in her honor. More than 100 people attend, including First Lady Dawn Ige and UH President David Lassner. The crowd includes students, faculty, and descendants of Molokai patients. In December 2024, after resolution by the UH Manoa Faculty Senate, a bust of Alice Ball is placed in Hamilton Library. It is the first permanent sculpture of her on campus. Her family background is revisited. Her father, James Presley Ball Jr., was a photographer, journalist, and lawyer. Her mother, Laura Louise Ball, left photography to raise the family. Her grandfather, James Ball Sr., was one of the first Black Americans to use daguerreotype photography. The family's work with chemicals may have influenced her interest in science. Alice moves from Seattle to Honolulu in 1902, then returns in 1905. She graduates from Seattle High School in 1910, excelling in science and drama. She attends the University of Washington, earning degrees in pharmaceutical chemistry and pharmacy. In 1914, she co-publishes a paper on benzoylation, becoming one of the first Black women in a major chemistry journal. She receives scholarships from Berkeley and the College of Hawaiʻi. She chooses Hawaii, drawn by its tropical environment and research opportunities. Her master's thesis focuses on Piper methysticum, the kava plant. She analyzes its active compounds, demonstrating expertise in natural product chemistry. Ullman, an acting assistant surgeon, seeks her help because of this expertise. Chaulmoogra oil, like kava, comes from a tropical plant with medicinal properties. Leprosy patients are isolated on Molokai, a peninsula with no escape. Over 8,000 are exiled there between 1866 and 1969, most of them native Hawaiians. The oil has been used since the 1300s, but Western medicine struggles to administer it. British physician Frederick Mowat introduces it in 1854, but it remains ineffective. When injected, the oil forms painful blisters under the skin. Patients describe it as feeling like bubble wrap beneath their flesh. Swallowing the oil causes nausea and vomiting. Many patients refuse treatment, preferring to live with the disease. Alice's method solves both problems. By converting the fatty acids to ethyl esters, she makes the oil water-soluble and injectable. The ethyl ester retains the antimicrobial properties of chaulmoogra. It enters the bloodstream without irritation. Her process is reproducible with standard lab equipment. No complex distillation is needed, unlike later claims. She does not live to see its success. Her death at 24 cuts short a promising career. Dean publishes, without crediting her. His papers mention Hallman and others, but omit her name entirely. Hallman's 1922 paper is the first to name her contribution. He writes, "I cannot see that there is any improvement over the original technique as worked out by Miss Ball." His words are recorded but not widely adopted. The medical community continues to credit Dean. The treatment spreads globally. Burroughs Wellcome produces aliceball, a commercial form of the ethyl ester, in 1927. By 1940, sulfonamide drugs replace chaulmoogra. Dapsone becomes the new standard, rendering the method obsolete. But for 2 decades, Alice's method improves lives. Thousands of patients benefit, many regaining mobility and social freedom. Her legacy is rediscovered in the 1970s. Takara and Ali published their findings, reigniting interest in her work. The university establishes a scholarship in her name in 2017, supporting students in chemistry and biology. A park in Seattle is named after her in 2018, honoring her roots. Her story gains media attention. Documentaries, articles, and school curricula begin to include her. The student government continues to push for renaming Dean Hall. They argue that truth matters more than tradition. In 2022, the Faculty Senate passes a resolution supporting the name change. The decision awaits administrative approval. Her bust in Hamilton Library becomes a site of reflection. Students pause to read her story, learning what was once erased. She is remembered not only for her science, but for what was taken from her. Her method saved lives, but her name was withheld for decades.